Hi everybody. I'm going to go through the use of Molview. It's a fairly simple program to use. It's online, it's free, and if you just go into Google and type in Mol, M-O-L, View, V-I-E-W, one word, right, it should be the first thing that pops up. So we'll hit enter there. Right, and here it is, Molview. Now I'm going to open it. Okay, and so what you'll end up noticing right here, you hit close. Now it usually has a molecule that's up. In this case it's caffeine, right? That's okay. You know, come up here to the where it has the garbage can on the upper left hand corner. Let me back up just a little bit. Okay, and you'll see that there is a garbage can up there, and what that will do is just basically delete your whole screen. Okay, right, and so right here, and when you put your thing on, it says clear all. Alright, so now this is where you're going to make your molecules. Alright, and you'll notice on the right side has the elements, on the left side it has different types of bonds you're going to use and whatnot. And on the top here there are some functions. Let me point out that this slides over right like that, okay? So first thing we're going to make is just hydrogen. So you pick hydrogen, put it there. Right now hydrogen has a single bond to another hydrogen. Alright, so it goes over. Now right now it assumes that carbon's there. Okay, so you have to go and add the hydrogen, get hydrogen, put it right on the end there. You see it turns green, and it goes like that. Now you can use the roller. If you hold down the right button, it goes like that. The roller in the middle makes it smaller or bigger. Okay. You will notice that up here, right, there are several things that you can do. Most of these you might not end up using too much. Right here, this broom, right, you might have to slide this over to the broom. You click on that, and what that will do is bring your structure together. So remember, this looks like a picture to you, but it's going to do some calculations. Okay, now the second thing you're going to do is 2D to 3D, right? You can see it right up there, and now it moved it over here. When you get these red things that pop up on the bottom, right, and it says don't show again, hit OK, and they'll just go away. Now this right here, you can use the roller in the middle to make those bigger, right, and you get an idea what it looks like. Okay, so that's hydrogen. So up here in model, right, you can try different things like stick, right, van der Waals sphere, wireframe, right, and line. But the best one to use, particularly when you're going to turn it in, is ball and stick, right? Because that way you can see the atoms and you can see the bonds in between them. Okay. All right. All right. So now we're going to go to where it says JMOL, right? And what we're going to do is click on JMOL. Go down here to distance. Okay. And I'm going to go from one to the other. Hold on. Over there. Right, so you click and then click on the other one. You might have to double click or triple click, and you get the distance, 0.076 nanometers. Okay, so this program runs in nanometers, right? That's also 0.76 angstroms, or it can 76 picometers with a P. So as you enter stuff, you're going to have to enter all three so you get comfortable with those. All right, and so that gives you this. Now when you copy this over to your, what do you call it? One thing is you can change the color of the background if you play around up here. I would leave it at white because when you put this into your report and you print it, you don't want to have a red background or green background because you might not be able to see the molecule and also kill your printer cartridge. Okay, and so what I typically do is I use snip. Right, so most computers have snip, S-N-I-P on them, and then go to new and just do like that. Take it over to your program, right, and you just copy it and then paste it into your Word file along with that. All right, so that's the first one, kind of simple. So let's say you wanted to switch this one to something else. What we can do is, again, this thing slides back and forth. This right here, the black and red, the black and white thing, it's supposed to be an eraser. You can come and click on something and then get rid of it. Right, and that took away both. Let's say we're going to do nitrogen next. So let's go here, click on N, put it in there. Now nitrogen to nitrogen is a triple bond, so you'll see this single, double, and triple over here. Right, you're going to click on triple, go over, and then do nitrogen again, and now you have nitrogen. Right, so you want to get the number of bonds right on your molecules. So rule of thumb, carbon has four bonds. Right, it can be 4 single, it could be 2 double, it could be a triple and a single. Right, nitrogen likes 3 bonds. Right, it could be a triple bond, it could be 3 single bonds. Oxygen likes 2 bonds. Right, it could be 2 single bonds or a double bond. Hydrogen always has 1. Right, so we're going to come up here, slide this bar over again, clean it up, right, and do the OK thing, get rid of the red thing on the bottom, and then do 2D to 3D. And so now you can see that this has the same thing. Right, it has you can see the triple bond. Right, the color of the molecule is not really important. When you pull it over, you want to make it a decent size. So we go up here to JMOL. There's something else. Now we can't do angles until we have 3 atoms, right? 2 atoms is just a line, right? Sometimes you can do dipole moments, right? But this right here is nonpolar, right? And sometimes you can look at charges here, okay? But all we're going to do right now is distance again, right? So we're going to put it here, go over to here, right? 0.111 nanometers. Okay, and that again, you're going to snip that, SNIP snip, and move it over. All right, so that gives you a feel. Okay, so let's jump up and let's look at another one of our things. So I'm going to come up here, right, and hit the garbage can. All right, get rid of that. So this stays over here, but it got rid of this. So now I'm going to do methane. All right, so I'm going to put carbon here. All right, so that's carbon. Now methane has 4 single bonds. All right, 1, 2, 3, and 4. Okay, and so remember, it assumes these are carbon here right now, so you have to go in and make them hydrogen. Click right on the end, and you get the hydrogen. Okay, I'm going to do the clean up thing. Go over here, clean it up. All right, so now it just looks like that. So in hydrocarbons, a lot of times it doesn't show the hydrogen because they're so common. We're going to go 2D to 3D. All right, now you see you have your methane. So this is where the program really starts to come in handy, right? Because 2D, it's pretty easy to see things and whatnot. So let's do a bond. So let's show 2 different types of bond distances. So we're going to go back over here to JMOL, and we're going to select our distance. And so we can go from H to C, right? And you see 0.109 nanometers. Okay, so that's the carbon-hydrogen bond distance. All 4 of them should be the same. But something you want to be sure, you can go from here over to here. Right, that's 0.178. That's hydrogen to hydrogen. Okay, so this carbon-hydrogen, that's typically what we're after. If you remember 1211, right, the geometry is always determined by the central atom. So this is a tetrahedral geometry. Right, and so when you draw this on 2 dimensions, it can look flat, like a T or a cross. But in 3D, it doesn't look like that, right? It looks a little bit different. So we're now going to do the bond angle. And how we do bond angle, oh, you can always hit this right here, energy minimization, right, and get rid of that. All right, it'll come in, and then we're going to do angle. And so we want to do hydrogen to carbon to hydrogen. Right, and I should have gotten rid of that right there, but it gives us our bond angle right there. All right, we can do it again, like here to here to here, right? 109.5. You can see that number right there, 109.5. Okay, and all 4 of those angles should be the same. Now, if you do the bond angle wrong, if you go from hydrogen to carbon, right, you're going to get a really small bond number because it's looking at this right here, and that's not what you're after. So when you do a bond angle, the central atom should be your second atom, okay? And so that's good old methane. That's a nonpolar molecule, right? It's a hydrocarbon. All right, so let's do something a little bit bigger. So I'm going to do the, let's come over here and hit the garbage can. And if you go over here 2D to 3D, it does it, but you see it doesn't change anything yet until you build something here new. So right here, this is a ring. This is an aromatic ring. Right, that's C6, H6. Right, I can make it bigger and smaller and slide it around. Okay, just so you see that. Whoop, now we have two of them. All right. But just so you see that that's what those over here mean. Right, so I can do like put one out here, and then have a single bond go say from this to this and connect them, and connect this and this one. And then when you do the cleanup, it does that. It rearranges it into a reasonable geometry, right? What it would look like, and if you could shrink yourself down. Well, let me and let's do 2D to 3D. Right, so you have it over here. Notice this little line here is junk, right? But it came up over here, right? So what I'd want to do is to come in, use the eraser, not the garbage can, the eraser, and get rid of it, and then come back over here and go 2D to 3D. Hit OK and OK. All right. So let's get rid of this. So as you go through this, let's say we're going to do let me show a molecule, a C6 molecule. So I'm going up here to single bond. 1, 2, 3, 4, 5. So I did 5 lines, but that's 1, 2, 3, 4, 5, 6. That's C6. Right? So that's C6. You notice that it doesn't show the hydrogens, although they're there. But let me just show you that real quick. Right? We can do the cleanup thing. It's going to rearrange it so it's a little better looking. Now it comes over here. Right? And you can see that it automatically attached the hydrogens to it. Right? This is a hydrocarbon. But let's say for the sake of argument, we're going to make an alcohol, which has 3 oxygens. Okay? So I'm going to do single bond up here. Say single bond here and single bond here. And then with the oxygen, I go here and then connect, connect, connect. Now, if you remember, oxygen likes 2 bonds. It has 1, 1, and 1, but it automatically did the thing over here. It added them up. And let me just show you what that looks like. Right, so we're going to clean it up. And now, and you see here, it actually adds them. And now we're going to go 2D to 3D. Right, and you can see that those oxygens, like this one right here, has a hydrogen on it, right? So that's an alcohol. It's a triol, three alcohols, 3 OH groups. Okay, and so when you see those lines, remember they represent carbons. Okay, now you can go in and say, oh, I want to make that one right there an oxygen. So you can click on oxygen, put it right there, and it's going to change it to an oxygen. Right? You can say, oh, I want to put fluorine on the end here. You can do that. Okay, so you can click on these and add things as you go through. Alright, so this should be pretty straightforward. Follow the rules. These are some basic molecules. You should feel comfortable with their geometries, their empirical formulas, and their names. Right, and this is a good visualization program that you can work with at home. Alright, and thank you very much.